In this video, we're going to look at calculating efficiency. This is incredibly important when it comes to energy transfers. So the important prior knowledge to understand this really is about energy stores and transfers. Remember, there are 8 energy stores and 4 pathways. I recommend, if you can't remember these at the minute, pause this video and refresh your memory. But efficiency is really important, as I say, when it comes to calculating energy transfer, and another way of wording that in physics is by calling that work. So we have to know a couple of things. We have to know what energy is measured in. And energy is measured in, that's right, joules. And that has a unit of a capital J, not lowercase, it needs to be capitals. And then we can calculate efficiency by the following calculation: that the useful energy transferred divided by the total energy, and we times that by 100, and that gives us an answer as a percentage. This one here will give us an answer as a decimal, and then we can times it by 100 to give a percentage. Remember that we cannot give an answer as an efficiency question. We cannot give an answer at, say, 0.4 as your decimal and just put a percentage on there. That is wrong. That is obviously 40%. So what is our total input energy? We can calculate that as well if we know our useful energy plus our wasted energy. So when we talked about the energy stores, we know that lots of waste energy normally comes in the form of thermal energy, and that's heat. Moving parts from friction generates heat, and that is wasted, and that's transferred to the surroundings. That is another key phrase. But it's this calculation we want to focus on today. So we've got Boris. He buys a new phone. It transfers 100 joules of useful energy from 150 joules of energy. So the first question here says, what is the input energy? Now, our input energy comes from this 150 joules of energy here. So this has to be one of the energy stores. And it's a phone. What do phones have? Where's the energy come from? Well, it comes from a battery. So what is that type of energy? That's right, it is chemical. So it has a chemical energy store, and that's our input energy. And what is the efficiency of the phone? Well, when we use our calculation, it is our useful energy, which is 100 joules, divided by our total energy. Remember, our useful energy cannot exceed our total. That is 150 joules. That must mean that there's 50 joules of wasted energy, and that's been transferred to the surroundings, more than likely as thermal energy. So we have 100 divided by 150, and then we can then times that by 1,000. And if you do that, we should get an answer around about 67%. So this phone is 67% efficient, which means the rest of that energy is going to be wasted, and we're paying for that. And that's something to bear in mind as well about the economic effects of efficiency. So Boris has got a brother, Keir. His new phone wastes 20 joules of energy for every 200 joules. So we've got a couple of questions here that are a little bit different this time, but ultimately we're looking at the same thing. So what is the useful energy amount? So we know our total energy is 200. It wastes 20. So to work out our useful energy, it's going to be 200, take away 20, and that is equal to 180 joules. So our useful energy amount is 180 joules. 20 joules is then wasted. And what is the phone's efficiency? Is it more efficient than Boris's? Well, we will find out. So our useful energy is, this time, 180. We divide that by our total amount of energy, which is 200. That gives us a decimal of 0.9, which when we times by 100, that is 90%. Let's have a look at rearranging this equation now. So we know that our useful divided by our total times 100 gives us our efficiency. But what about if we want to find the total input? Well, we've got to turn that decimal turn that percentage back into a decimal. And then to work out our total, we rearrange the equation. It's going to be our useful energy transferred divided by our efficiency as a decimal. So let's have a look at a question then, what that might look like. We know we have a computer and it's 85% efficient, which means obviously 15%, all right, is going to be wasted. But it usefully transfers 100 joules of chemical energy. What is the total? So we want to look at our total energy. So we've got our efficiency as a percentage, and we've got what it usefully transfers. So if it's 85% efficient, that as a decimal is going to be 0.85. So our useful energy is going to be 100. We divide that by 0.85. And that was equal to, put your calculators, 117.6 joules. So if we have 117.6 joules, 100 joules of that is going to be usefully transferred. 17.6 joules is going to be wasted. A lamp transfers 70 joules of energy usefully. It's 60% efficient. How much energy was inputted? So again, let's have a look at this. We've got 60%. That is going to be 0.6. And we've got 70 joules here. So what's our useful energy? Well, it's going to be 70 divided by our decimal efficiency. So 70 divided by 0.6, and that comes out around about 116.67 joules. And another one we can look at, if the efficiency is 55% and the device has an input energy of 180 joules, how much energy is transferred usefully? Well, for this equation here, all right, once again, what do we know? Well, if we have a reminder, it's going to be our useful energy divided by our total energy. That is equal to our efficiency. So remember, I've said there's a video earlier on in Mastering Physics that you might want to have a look at on the FIFA method. Let's input what we know as a decimal, and that's going to be 55%. So the efficiency is 55%. That is going to be equal to the useful energy, but we don't know what that is. So let's keep that as U still. And do we know our total? Well, yeah, our total input energy was 180. So if we rearrange that, it's going to be 0.55 times 180, 99. 99 joules is going to be transferred usefully out of 180 if a device is 55% efficient. So, next up, we've got 5 questions here. What is 10% of 206, 25% of 752, 50% of 80, 33% of 4,200, and 82% of 666? Pause the video, give yourselves 3 minutes, and then let's see if you get the answers right. Okay, so let's have a little look. So how we do these, we have to convert those percentages back to decimals. So it's 0.1 times 206, which is going to be equal to 20.6. Remember, we always need to show our working out in physics. That is incredibly important. 0.25 times 752. That's 188. 50% of 800. Well, that's just half of 800. So you might know that straight away. And you might think, well, I know that's 400. But again, if that's 2 marks in a physics paper, you'd only get 1 mark. So you have to show your working out, which would be 0.5 times 800. 33% of 4,200. And that's 1386. 82% of 666. So 0.82 times 666. And that's something like 546.12. So I hope that helps you become more confident in tackling efficiency questions. Good luck.